Please welcome to the stage a representative from Boston Dynamics.
Thank you very much, and thanks for your patience as we worked out a computer issue, not a robot technology issue. I'm Brendan Schulman. I'm Vice President of Policy and Government Relations at Boston Dynamics, and I work with government officials and staff to help understand the robotics ecosystem, the convergence with AI that we'll talk about a little bit later, and also try to gain support, government support for the robotics industry. I brought with me today Spot. Obviously, you're here for the Spot demo, so what we'll do is we'll ask Spot to come up on stage. Spot is the most advanced mobile robot in the world and navigated the stairs automatically, as you see. One of the challenges I have when I bring Spot to an expo or a trade show is that there's all these carpets and flat floors, and it doesn't really show off the mobility and dexterity of the robot. So I went to IKEA and I bought these very flimsy plastic bins. Yesterday I actually broke one, if you were at the demo here yesterday. So we'll see what happens, but this will give you some idea of Spot's ability to navigate over uneven terrain. Imagine these are rocks or debris. And you'll see that Spot, which I'm just commanding to move forward, is going to automatically figure out where to place its feet. Some of these boxes may go flying because they're very lightweight. So Spot is figuring out sort of where to place its feet, sometimes between and sometimes on these boxes. So if you imagine an environment with rocks or sticks or debris, you're going to have a robot that's able to traverse that. This Spot is equipped with an arm, so we can actually kind of play fetch with the robot. Take this dog bone from the pet store. If I just tell Spot that I want it to pick up the object and I point on screen to what that object is, Spot's going to automatically identify the object, walk up to it, visualize it, turn the gripper at the right angle, and grab the object. Once Spot has the object, I can say, all right, you got it. Please carry it, and sort of bring it over. So if you imagine a public safety application, could be a suspicious package or something, Spot can move that out of the scene or out of the way. Actually, we've had public safety officials use the robot to remove weapons from the scene when there's a dangerous situation with a suspect. Because Spot is dynamically balanced, another thing that people might remember from our YouTube videos is people kicking the robot. I'm not going to kick the robot. I kind of think it's a little mean, but I'll give the robot a good push. You can see how the robot keeps its balance even if there are forces acting on it that would otherwise upset it. And then finally, as part of the demo, before we talk a little bit about AI, I'm going to show you a little bit of a demo dance. Everyone wants to see the robot dancing. When you have a robot with legs, you can make a dance. So what you're going to see is a programmed sequence of moves. I don't have music here today, so you can imagine the music with the robot doing a little bit of a dance for you. And take a bow. Thank you. So as I mentioned, I do advocacy. I work with government officials. We're trying to promote a national strategy for robotics, something that SCSP has also said would be a great idea for the United States as we work on competition. That could be in the form of agency action. It could also be legislation. So while I tell you a little bit more about AI and robotics, I'm going to have Spot carry this bill near Capitol Hill. So when it comes to AI and the convergence with robotics, my starting point is all the things that we talk about when we think about AI tend to fall into the category that I would refer to as intellectual output. And those are things like art, image generation, language generation. You could have poems, you could have college essays, though maybe you shouldn't. You can have videos. There have been a sort of an enormous number of video-generated clips that are very impressive lately online that I've seen. Healthcare applications, education, companionship, data analytics, all the things that you see on the floor here today. It's typically what people think about, at least these days, when you talk about artificial intelligence. And of course, those kinds of technologies have raised concerns, maybe some risks that folks in government and folks in industry have been working on. Those are issues of bias, misinformation, privacy concerns, discrimination, inaccuracies, labor displacement concerns, of course, and even things like bioweapons. These are all concerns that come out of these intellectual outputs of what most people think of as AI. But AI is also increasingly empowering the robot ecosystem and really converging with robotics in a way that is making the robots more capable and more useful in a variety of industries. When we think about sort of what a robot is, a lot of people have had in mind for decades sort of two things. Number one, maybe the science fiction, Terminator, Black Mirror type scenarios, but also when it comes to useful robots, I tend to think of these decades-old technologies involving robot arms in factories bolted to the floor, doing one repetitive task all day long. That could be a welding step in a car assembly process, could be moving boxes in a warehouse, but typically the robots are out of sight, they're in a controlled environment, and they're not really moving, or they're moving very little in those industrial spaces. But we've now entered a new era of robotics, including Spot and other products that you may see out here. And that's a world in which the robots are entering other environments that are not structured. So you've got, here are a few examples. You've got Spot walking up and down stairs, in the top center, Spot in a mine, helping with the mining operations there. In the top right, we'll talk about this a little bit more, specifically public safety operations. Bottom left is not a legged robot, but that's our stretch robot that's for automated warehouse, using AI to identify where the boxes are and pick them up with its gripper and put them into the warehouse. And then in the bottom middle, Spot is operating at Pompeii, helping the archaeologists map the site and preserve the ancient ruins there. In the bottom right, something I can't show you here because we don't have access to a door, is Spot using that same arm and gripper to autonomously open the door, because of course as robots work in places that are constructed for humans to work in or to live in, there are doors and there are stairs. So what we've created, and this really goes all the way back to our founding at MIT by Mark Rabert, who's a scientist working on what he called the leg laboratory. This goes back to the idea that we need robots in more places doing more things, and we can't be constrained by the old way of making robots move, which is typically wheels and tracks, right? Because the wheels can't get you up the stairs typically, and tracks can't get you over uneven terrain. Here's another reason why the convergence of AI and robotics is so important. We have a demographic issue in the world. The entire world has this problem, and also increasingly in the United States. We are not having enough babies to produce the workers that we will need to continue to make things that we all need in our lives. And for that reason, increasingly we're going to need to automate manufacturing. We're going to need to automate industrial processes, which includes software in those environments, but also increasingly physical AI-powered robots. Some examples of how we're already putting robots to use today in the sort of manufacturing, industrial, and public safety context. Global Foundries is a semiconductor fabrication plant in New England, and they're using Spot to do automated maintenance, patrol, inspection missions to detect whether components in their factory are overheating, which is something that you want to catch early on before it brings down the factory. So you basically have an inspection robot running 24/7 autonomously, not like the demo I showed you today, which was hands-on with the controller, but a real AI-powered automated inspection with the robot that can detect anomalies in the factory and report them to the maintenance department before there's a real problem. It can also read dials and gauges and take that information and put it into the digital management system. So you've got a real way to revolutionize and make more efficient these other industries by putting the robot into the environments. Even something like food and beverage is another great example of using robots. So this is a customer of ours that has Spot monitoring 1,400 individual inspection points. That's 23 kilometers per week. And again, detecting issues before they're real problems and really bringing value to those manufacturing operations. Energy is another industry that's benefiting from robotics. So here's a pilot program, including in sort of traditional electrical generation, but also, of course, radioactive environments, nuclear plants, where you can have the robot inspect for leaks, detect radiation, or be used for decommissioning or construction projects. And finally, really my maybe personal favorite application for these kinds of advanced robots is public safety. And these are examples of real, actual outcomes where people were protected thanks to a robot. So in St. Petersburg, they had a 3-year-old child who was kidnapped, driven away in a pickup truck that then was crashed off the side of the highway. This was an uneven terrain scenario with a potentially armed suspect and a 3-year-old child. Obviously, law enforcement wanted to rescue the child safely. That was the top priority, but needed to understand whether there was a weapon inside the truck. So as you can see in the pictures here, they used Spot to walk out to the truck and used the camera in its arm to look inside and determine that there was no weapon and that a rescue could be safely conducted, which it was, and they were able to bring that child back safely. And then we've actually had a robot that's been shot. So in a domestic violence situation involving an armed suspect, law enforcement sent in the robot to basically do reconnaissance, situational awareness, using the cameras on the robot to feed back a live video image to the officers and determine what's going on in there. Well, the suspect, upon seeing the robot, shot it 3 times. Now, from our perspective, that is an amazing outcome. That is a robot that took bullets instead of a person and really validates for us the utility of the machines in dangerous, hostile, or high-risk environments, including public safety, but also factories, warehouses, nuclear power plants, et cetera. So you have robots that are automating industries, and you have robots that are keeping people safe from harm. So the convergence of AI and robotics, to give you some examples of how we are using AI to make the robots better at those kinds of industrial and public safety missions. This was work that we did in response to customer feedback from one of those beverage manufacturing facilities. It was actually a beer plant. So if you ever go to a beer plant, apparently the floors are covered in beer, which kind of sounds fun, but also dangerous. So for the robot, we had Spot in there doing its inspection rounds, but the robot kept slipping and falling over, which is not a huge deal. Spot can get back up after it falls. But if you have the robot falling several times a day, at some point, maybe something's going to break, and you're also impacting the efficiency of that mission. So you don't want the robot to fall very often. So the customer asked us, can you make Spot better at walking across our slippery floors, or for that matter, ice, right? If we have Spot used in public safety, and the highway that you saw from that rescue was covered in ice, we want Spot to be able to navigate across a slippery surface. So we used reinforcement learning, right? So reinforcement learning, also known as AI, is the way that we got the robot to train itself to walk across a slippery surface. In this case, in the lab, we have a plastic sheet covered in oil. And I'm going to show you some clips now that will show you the before and the after. So this is the before, and you'll see Spot is walking, but then eventually slipping, falling over. And this is after the reinforcement learning. I don't think I could tell you deterministically how the robot is programmed to do that. The robot is training itself. And there you got before and after, left and right, again on an oil-covered plastic sheet. So this is research work we did in our lab, and then we updated the software and released it to our customers. So now the Spots that are out there in the world have this built in as a software update, thanks to AI. So we are making the robots better at what they already are good at, protecting people, making industries more efficient, getting things done in a factory that are dangerous, dirty, or dull. And we're doing it through AI, and this is increasing the pattern in the industry. Give you one other example here. So as you saw, Spot can walk over plastic boxes and a lot of other things. If the obstacle is a foot or less, Spot's going to step on it. If it's a foot or higher, it's going to try to walk around it, which works most of the time. But there are things in the world that are less than a foot high that are probably not a great idea to walk over. And those include things like electrical cords, rolling dollies that might be in a warehouse or a factory, and ladders, which you probably don't want the robot walking under Maybe you're superstitious that way. I don't know if that applies to robots, but that is a little bit of a safety hazard. So we identified those as things that Spot should learn to recognize in the world using image recognition. So there's your AI model, your foundation model is like what's around here in the world. Get the robot to learn those things and say, you know what, if you see an electrical cord, if you see a dolly, walk around those automatically. Don't walk over them, even though you could. So to give you that example here, so this is the before, and you will see Spot getting caught up on these cords and either stuck or dragging things and potentially knocking things over and creating a safety hazard. And here's the dolly cart. Again, Spot could walk over that, but once Spot is on it, it's going to start moving. And that movement is going to confuse the robot and cause it to fall. So with the image recognition, we have this result. Again, this is autonomous. So Spot's walking around the ladder instead of under it, walking around the cord, looking for a path around instead of under, although it could fit under the ladder. And then when it gets to this cart, instead of stepping on it, it's going to walk around it. So those are ways we're making the robot, the existing robot that was developed arguably before the AI software revolution that we're experiencing now, making the existing robots better. We're also developing new robots. So some of you may know we have our Atlas humanoid. We're working on the electric version, which is this. Some people think this is a little creepy. We've put extra joints into the robot compared to the human body, which makes the robot better at efficiently navigating the environment. So the goal here is to create a humanoid robot that can work in spaces that are designed for humans, and thereby be helpful in a variety of industries, but to do it in a way that's actually more powerful, more capable than humans. I'll run that again just so you could take a look. So the purpose of the extra joints, which I'll show you in the next clip, is really to enable the robot to move in ways that are more efficient in the environment. And then here's the first application that we're working on for the new Atlas. This is parts sequencing in an automotive factory. So what you're going to see is the parts come in on one cart with flat trays, and they have to be moved to the other. The robot on the left, that's the robot's perspective. It is autonomously identifying the spaces in the cart where there are parts, recognizing what kind of part it is, moving it over to the other side, and placing it in the bin. You'll notice here the robot actually encounters some resistance. Rather than failing, it's going to recover and try again. So these are all autonomous learned behaviors, and this is really the next generation of robots for us, not just being the humanoid form factor, but really using the AI, the image recognition, the reinforcement learning to get the robot to do things that they wouldn't otherwise be able to do. So that is my demo and presentation. Hope you enjoyed it. We have a booth sort of about midway back. If you have any questions or want to interact more directly with Spot, would invite you to come over there. I'm there today and tomorrow as well. And thank you for your time.